Have you ever looked at the periodic table and wondered if there's a specific neighborhood where all the cool, weird, and truly essential elements hang out? Well, there is, and it's called the P block. It might look like just another chunk of the table, but this block is where the magic really happens. It's home to an incredible mix of elements, from the metals that form your soda cans to the non-metals that make up the very air you breathe, and even the strange metalloids that power our digital world. Stick around, because we're about to dive into the wonderful weirdness of the P block and discover how its unique properties are the foundation for, well, almost everything important. So what exactly is the P block? It's that rectangular block on the right-hand side of the periodic table, spanning groups 13 to 18. The P in P block refers to the p orbitals, which are the outermost electron shells being filled for these elements. Think of orbitals as the specific paths electrons take around an atom's nucleus. For P block elements, the last most energetic electrons are settling into these p orbitals. This might sound a bit technical, but it's the key to everything that makes them special. The way these p orbitals fill up gives these elements a range of personalities you won't find anywhere else on the table. Let's start with the sheer diversity. On the left side of the periodic table, you have the S block, full of highly reactive metals. In the middle, the D block gives us our classic transition metals like iron and copper, but the P block? It's a true melting pot. You've got metals like aluminum and tin, metalloids like silicon and germanium, and non-metals like carbon, nitrogen, oxygen, and all the noble gases. This is the only block that contains all three types of elements. Why? It all comes back to those electrons. As you move from left to right across a period in the P block, atoms are gaining more electrons and protons. This increasing nuclear charge pulls the electron shells in tighter, making the elements less metallic and more non-metallic. This gradual change is what creates such a fascinating spectrum of properties all in one block. One of the most mind-bending features of the P block is something called the inert pair effect. This sounds complicated, but it's a cool quirk that mostly affects the heavier elements at the bottom of the block, like lead and bismuth. Normally, you'd expect an element to use all of its outermost electrons for chemical bonding. But for these heavyweights, the two electrons in their C orbital, which is just inside the P orbital, sometimes decide to just sit back and do nothing. They become inert. This means lead, for example, can act like it has two fewer valence electrons than you'd expect. This effect explains why lead can form stable compounds in different oxidation states, a kind of chemical flexibility that has been useful, and sometimes hazardous, throughout history. It's one of the P block's little rebellions against the normal rules of chemistry. Now, let's talk about the element that is arguably the king of the P block, and maybe the entire periodic table, carbon. Carbon is in group 14, and its ability to form 4 strong covalent bonds with itself and other elements is the basis of all organic chemistry. It can create long chains, complex rings, and intricate three-dimensional structures. This property, called catenation, allows for the incredible diversity of organic molecules, from the simple methane in natural gas to the complex DNA that codes for life itself. No other element can do this with the same stability and versatility as carbon. Without carbon's unique position in the P block, life as we know it simply wouldn't exist. It's the ultimate building block, but carbon isn't the only star. Right next door are nitrogen and oxygen, the main components of our atmosphere. Nitrogen, with its incredibly strong triple bond in N2 molecules, is fairly unreactive, which is great because it dilutes the highly reactive oxygen and stops our planet from being a giant fireball. Oxygen, on the other hand, is the powerhouse of respiration, the electron-hungry element that drives the metabolic processes in our bodies. Then you have phosphorus, just below nitrogen, a key component of ATP, the energy currency of our cells, and the backbone of our DNA. You see the pattern? The P block isn't just a collection of elements. It's the life support system of our planet. The weirdness continues with the metalloids, the elements that walk the line between metals and non-metals. The most famous of these is silicon, another group 14 element just below carbon. While carbon is the basis of life, silicon is the basis of the digital age. Silicon is a semiconductor, meaning it can be tweaked to control the flow of electricity. By adding tiny amounts of impurities from its P block neighbors, like phosphorus or boron, a process called doping, we can create the transistors that are the building blocks of every computer chip, smartphone, and electronic device you own. The entire information revolution is built on the precise and peculiar electronic properties of a P block metalloid. Germanium, Its neighbor plays a similar role. This semiconducting ability is a hallmark of the p block's unique electronic structure. Let's not forget the halogens in group 17: fluorine, chlorine, bromine, and iodine. These are the most reactive nonmetals on the table. They are just one electron short of a full outer shell, making them desperate to grab an electron from wherever they can. This extreme reactivity is incredibly useful. Chlorine disinfects our water, making it safe to drink. Fluorine in our toothpaste strengthens our teeth by forming a more resistant layer on our enamel. Their p-block neighbors, the noble gases in group 18, are the complete opposite. With their p orbitals completely full, they are the most stable and unreactive elements of all. They are so content with their electron situation that they rarely form compounds. This stability makes them perfect for things like filling light bulbs, argon, or creating an inert atmosphere for sensitive welding, helium and argon. So from the metal that holds your drink, aluminum, to the gas that fills party balloons, helium. From the carbon that forms your body to the silicon that powers your phone. From the oxygen you breathe to the chlorine that cleans your pool, the p block is everywhere. It's a story of incredible diversity, driven by the subtle, step-by-step filling of p orbitals. This block shows us how small changes in atomic structure can lead to a vast spectrum of chemical behaviors, from the most reactive to the most inert, from metals to nonmetals and everything in between. It's this weirdness, this variety and flexibility that makes the p block the source of the most important materials for both technology and life itself. The next time you look at a periodic table, give a little nod of respect to that block on the right. It's the block that builds worlds. Thanks for joining this journey through the p block. If you found this as fascinating as I do, hit that like button and subscribe for more deep dives into the amazing world of science. Let me know in the comments which p block element is your favorite and why. See you in the next video.